There are many good things about being a professor in a research university. But if I had to pick the one thing that's at the top of the list, I would say that the best part of the job is the ability to create, to think creatively, to ask why not, to try things out, to think about new ways to approach given problems, to see where the road will lead, sometimes in tortuous ways, to be able to build on that knowledge gained along that road, and to create something that never existed before, and to see it implemented in the end down the line. That's got to be the most enjoyable part of the job. I have been doing research for more than 2 decades on concrete-filled steel tubes and steel plate shear walls for seismic and multi-hazard applications. In some odd ways, one can think of a concrete-filled composite steel plate wall as like putting the two systems together into one to get something completely different, and that is also known as the SpeedCore system. More than a decade ago, we did investigate the cyclic and elastic flexural behavior of these walls. This provided useful information in support of a new clause H7 added to the AISC seismic provisions. More recently, in collaboration with Amit Varma from Purdue University, we have expanded this research to address core wall systems, typically used in mid and high-rise buildings. This work was funded by the Charles Pankau Foundation and AISC, and it has supported the inclusion of new design provisions in ASCE 7 and in the AISC seismic provisions for SpeedCore in coupled wall system configurations. This was all made possible with the hard work of many graduate students who are listed on my websites and who have participated in the development of complex numerical models and in the conduct of large-scale experiments. This work made it possible to better understand the ultimate inelastic behavior of these walls. It has been a lot of fun, and it continues to be. Predictions are always difficult, particularly predictions about the future. The fact, though, is that this structural system has many advantages. It is ductile for seismic applications. It provides considerable strength, particularly shear strength, which is important for walls. It is fast to construct because it eliminates the need for reinforcing bars. It uses the steel plates as formwork, and it is built off-site for construction, high construction tolerances. So what is there not to like? Maybe the question to ask is not what impact it will have on the building industry, because the impact will be there, it will be significant. The more intriguing question is how long it will take for the system to become as commonly used as other structural systems. Structural engineers can be slow or fast adopters of new ideas. 20 years is not uncommon before a new structural system becomes mainstream. However, in this case, seeing the construction of the 58-story Rainier Square project in Seattle was like watching history being made. This should significantly accelerate the speed of adoption. This is a question I often get and a logical one to ask, but to me it sounds as if the question was, what has inspired you to breathe? And this is because there's never been a point in my life when I decided I wanted to write. As far as I can remember, I've always been writing. In grade school, if we had an assignment to write 1 page, I wrote 4 crazy ones. I wrote my first novella when I was 18, but that's one book you're never going to see. A key question might be, what are the specific topics that inspire me to write or that drive me to write? Strangely, I do not quite control that either. Fundamentally, I believe that a novel should be enjoyable to read and entertaining, while at the same time expressing a view of the world, the view of the author. Having writers come from different backgrounds is valuable and essential because it contributes to diversity on human perspectives in literature. So hopefully I bring one such different perspective. And I am lucky because all of my 3 novels have been well received. even though they are quite different from each other, as different as three siblings from the same family. They each have their own particularities, quirks, characteristics. There's the pessimist kid, there's the optimist kid, and then there's the weird one, and I will let you figure out which is which. Leonardo da Vinci. I would have liked to hear him talk on his latest engineering ideas, because he was an engineer before the term even existed, but also on everything else. The goal would not be to hear stuff that is in every biography of Leonardo da Vinci, but rather to observe firsthand how he thinks, how his ideas evolve, how he reconfigures his brain on the fly to juggle with creativity in the arts, philosophy, engineering, science. And as a bonus, maybe I would have got to meet the mysterious Mona.